In our last video, we talked about momentum. So picture, I've got this baseball that I've thrown and it has mass and it has a velocity, so it has momentum. But now if we think about what happens when that ball hits a wall, and we can talk about Newton's laws, well, we know that the wall is going to exert an equal and opposite force on the ball. So as the ball hits the wall over here, what happens to the ball? Well, it's going to change direction and it's going to bounce back. And the force exerted by the wall and the amount of effort is related to something called impulse. Impulse is represented by the letter J. And it really is about a change in momentum. So imagine um, that we've thrown our baseball at the wall here. Let's just say that it has a momentum of 5 kilogram meters per second. And then the ball hits the wall and it bounces off. And let's say it bounces off and it has a new momentum in the opposite direction of 4 kilogram meters per second. What was the impulse of the wall? Well, what we're looking at is how much did the momentum change? And the momentum changed by 9. It was moving in this direction with 5, and now it's moving in that direction with 4. So it had a net change of 9 kilogram meters per second. The impulse, J, is influenced by two things. First of all, how much force was applied to cause it to have this change in momentum, and how long was the force applied for? The longer you apply the force, the greater the result that you're going to have, so the more impulse. So as an example, let's say that we applied a force of 125 newtons. And if we did this for, let's say, 0.1 seconds, we would simply multiply those together and we would see that we had an impulse equal to 12.5 kilogram meters per second. Or if I look at the units a little more closely here, we'll see that newtons times seconds, because the force is in newtons and the time is in seconds. But let's keep that in mind, that a newton is a kilogram meter per second squared. And then we multiply that by seconds. And when we do so, we'll see that the seconds here from the time will cancel out one of the seconds down below. And we'll end up with the kilogram meters per second, which is what we already knew was the units for impulse. So let's consider another question. So here we have a hockey puck with a mass of 120 grams, and I'm going to right away put that into kilograms. And it is passed with an initial speed, and we see that the speed here is not in the units we'd like. I've given it to us in kilometers per hour. So we're going to have to figure out how to fix that. And then this is hockey people call this a one-timer. It returns in the opposite direction. So here's the puck moving in this direction with a speed of 15 meters per second. And then it gets slapped back that way with a speed of 60 kilometers per hour. Kilometers per hour. And it gets slapped back that way. And the first part of this is, what is the impulse, J? Well, then we also see that we have a time here 0.0158 seconds. So we want to know what force was used. So I think what we'll do is we'll start off by converting our units here. So I have 15 kilometers per hour. So 15 kilometers per hour. And to convert that, well, I know that there is 1,000 meters in a kilometer. And I'm going to put it this way because I see the kilometers up here on top. So I'm going to put the kilometers down here on the bottom to get rid of those. And now I have that into meters, which is what I was looking for. I'm going to do the exact same process here to get rid of hours. I have hours on the bottom. I'm going to put hours up top here. And I know that 1 hour is equivalent to 60 minutes. So now my hours on the bottom are gone, but I've got meters per minute, and I don't want meters per minute. So once again, I'll put minutes up top, and I know that 1 minute is 60 seconds. So my minutes on top and my minutes on bottom will cancel. And what I'm left with here is I'm left with 15 times 1,000 times 1 times 1. So that's 15,000 divided by 1 times 60 times 60. Watch your order of operations on your calculator. Make sure you do this correctly. And what you should see for an answer is our our velocity here is going to be 4.16 repeating meters per second. Okay, so that's our initial velocity is 4.16 repeating meters per second. I didn't write down my second one here, my 60 meters per second. So it's my new velocity, and it was 60 kilometers per hour. And you should practice solving that, but hopefully you're going to be able to figure that out, that is equivalent to, well, it should be 4 times that one. It's going to be 16.666 repeating meters per second. Okay, so I've got everything I need here. I've got my mass in kilograms, and I've got my velocities in meters per second. So what I can do, and there's more than one way of doing this. I'm going to do it the long way the first time. I'm going to say that my first momentum, my J, was equal to its mass times its velocity. And so I had a mass of 0.120 kilograms. And it was moving at 4.16 repeating meters per second. And so I had an initial velocity here, an initial momentum here of 0.5 kilogram meters per second. And that's before the puck touched the teammate's stick. And then, and so that was moving. I should give this a direction because it's a vector. So maybe it's moving in the positive direction, or maybe I can just say it's, maybe it's going to the left, and now it's going to move to the right. Or I could have said the positive direction here, and then it's going to go in the reverse direction here, or negative direction. Negative, don't see it as a negative connotation, just it's a change in direction. It's in the exact opposite direction. Okay, so our second momentum will be mass times velocity, and we have 0.120 kilograms times our new velocity of 16.666667 meters per second. And what we're going to see is this comes out to be a really tidy number at 2 kilograms meters per second. Okay. So the first question said is the impulse. What is the impulse? Well, the impulse, that's what the stick did, impulse caused by the stick. So it was moving this direction at a 0.5. It hits a wall, and now it's moving this way at a 2.0. So our impulse, J, is 2.5 kilograms meters per second in that direction. Okay, that's the direction. I got to give it a direction. So the impulse was to the sorry, I got my directions backwards. Initially, it was moving left. Let me back up here a little bit. That was going in the opposite direction. I said right and left. Let's make sure we get these correct. It was going left, and it hit a wall, and now it's going right. So it hit the wall, and it's going this way. So this was my positive direction, and this is my negative direction here. All right, so now it's got an impulse of 2.5 kilogram meters per second in that direction, which is the right. So let's make sure we get that in the correct spot. Okay. Now the second question here was, okay, what was the impulse? We answered that. But now I want to know, what force did the stick hit the puck with? Okay. Well, we know that our impulse is equivalent to the force multiplied by the change in time. And we know our impulse, we know our time, so we can just do the little algebra there and figure out what our force is. Okay, so it will be 2.5 kilograms meters per second divided by, and the time in this question, 0.0158. 0.0158 seconds. Okay, and when I divide that out, we'll see that it was given a force equivalent to 158 newtons in that direction. And there we are. So far that we've seen that the impulse, represented by the letter J, can be figured out two different ways. First of all, J is the change in momentum, or that the impulse J is equal to the force times a change in time, or the time that the force was being affected onto the object. Okay, I want to take this first one, and let's talk about this momentum for a moment. First of all, what we did here is we took the mass times the velocity. Now, we have to be very careful on our signs, our positive and negative. And the positive and negative represent the direction. Okay? So I'm going to say that our first momentum was the mass times the velocity, and our second momentum was the mass times the second velocity. And one of these was in a negative direction. So I'm going to use this as being a negative direction here. So the change in momentum was the mv2 subtract the mv1. But just keep in mind that one of them is negative, and I'm going to suggest it was the first one that was negative. Okay. So what we could say is that the change in momentum, if we factor out the mass, it would be the V2 take away V1. And going way back to our kinematic stuff, we know that V2 take away V1 is just our delta V. So there we have a new formula for thinking about our change in momentum. Our change in momentum is the mass times the change in velocity. So let's add that up to our other equations here that we've got. So our impulse is the mass times the change in velocity. And let's just do that for our equation here and just see if that really works. So using the previous example, we wanted to find J. And so I'm going to say, well, our J is our mass times the change in velocity. Okay. So let's see. What was the mass of that hockey puck? Well, it was 0.120 kilograms. And we're going to multiply that by our change in velocity. So we're going to take our second velocity, which was 16.66667 meters per second. And then we're going to subtract. But remember, this had a negative speed, okay? And it was 4.1666667. Okay, so we're basically adding those two things together. So I've got 0.120 kilograms being multiplied by, I've got 21.83333, etc. meters per second. Okay, so just watch the signs. And when I do that, and you multiply that out, you're going to see that I've got an impulse of 2.5 kilograms meters per second. So it does indeed work out. Okay, so we can use this m delta v. Just be really, really cautious on the signs of the velocity. One of them will be positive, one of them will be negative if it switches direction. Okay. Now, having said that, we can also put some of these equations together. So I could say, for instance, I could say delta p equals f delta t, or I could say delta p is m delta v. Or I could even say that f delta t equals m delta v. And these are all variations of those three original equations that we have here at the top.